In this video, I'm going to show you how to set up 0 reference pins on your machine for the lower left corner and show you how to set up a work offset so that you are in the right spot every time when you start a job. So to best illustrate what I want to try to do here on the CNC with regards to putting in left and bottom edge alignment pins, I'm going to use Vectric here. So what I did was I created a series of holes on a layer, and I want to talk about this for a minute. So what I'd like to do is I want to move the gantry all the way to the left and all the way to the front of the machine. So that's the max extremities that your machine will go. And what I'd like to do is on that axis, I would like to add 2 dowel pins in the y-axis and 2 dowel pins in the x-axis. So these dowel pins are going to be a 1/4 inch, so they're 1/4 inch steel pins. You can get them from McMaster Car, or a lot of hardware stores carry them, but they're precision pins so I wouldn't use wooden dowels. I like to use steel pins for this. And you also want to make sure that your table is something that you can actually mill into. So if you have like a MDF spoil board on top of your table, that's fine. But if you're using an all aluminum table, you might want to think twice before you start boring holes into it. On the machine that we're going to put this on, we have a MDF with aluminum T-tracks, and these pins will actually fall right in the MDF section, so it'll work out fine for this. Now, as you watch this video, I know that many of you are going to say, oh, I wouldn't use dowel pins. I would use like an L-shaped edge or 2 guides or something like that. Yes, there are a lot of different ways that this can be done. I am just for this video showing how to do it with dowel pins. I will probably do a follow-up video showing a couple optional ways of setting these guides. But the repeatability factor is really what I'm going for here. I want to make sure that when I put material on my CNC machine, that it's referenced in an exact location every single time. Now, some of the bigger industrial machines will actually have pins that are pneumatic or electric, and they pop up from the bed, and that's really cool. It's an expensive proposition to put on a machine, but for those of you who are using, hobby grade machines, or just can't put an electric, type system in, the steel dowel pin method works really, really well. So if this white boundary is the material that I'm going to put on there, what I want to do, like I said, is I want to put the dowel pins at the maximum extremity of my movement for X and Y to the left and to the bottom. And what's going to happen if you do that, when you put your material in, which is represented by this white square here, you'll notice it's up against all 4 pins, right? So that gives me a nice square reference location. However, if you look close here, this is the 0, 0 location, all right? And the problem with this is that if you were to zero your machine here and then start your job, your results on your work area are going to be 1/8 of an inch off in both directions from what you're expecting, okay? So to illustrate this here, I'm going to draw a 1-inch square, and I'm going to have it be 1 inch in from the edge of the material and 1 inch up, okay? So we're just going to draw the square here. Now, the distance between the edge of the material and the edge of the square that I want to cut is 1 inch. However, if my 0 reference point is right here for 0, 0, because my pin is outside of the work area, and CNC runs based on the center of the end mill, not on the edge. So when you program in Vectric, or pretty much any CAD program, it's always based on the center of the end mill, right? So if this is a 1/4 inch end mill, then that means from the center to the edge is 1/8 of an inch. So when I go ahead and I cut this on the material, I'm actually going to have the end mill move over to cut on the edge of this line. It's going to be 1/8 of an inch to the left and 1/8 of an inch down, so this square will not be accurate. So how do we fix that? Well, we want to keep the dowel pins here because that's the maximum extremity to the left and bottom edge. So we want to maximize our work area. So those pin locations are fine. However, we want to make sure that we are always zeroing based on the corner here. So I'm going to turn this layer off and turn this one on. Okay, so here's what we actually want. We want to make sure that our 0 location is actually right here. It's this end mill center axis is going to be right on the corner of the material. And that, because that's how Vectric references a job. And it's evident right here. Look at when I have this job set up right now for a lower left corner datum. See the red square there? If you notice, that red square is split. So it's right on the edge. It splits the Y and it splits the X. And you can further see that by looking at these crosshairs right here. Okay, the gray crosshair lines. That Vectric puts those in as a reference location. So that means that when you look at the cross of the X and the Y, it's right on the center of the material, right on the corner. Okay. So in order to do this, that means we have to program in an offset into our machine to be able to offset over from the position of the dowels. Now, we're using UCC CNC here, and we made a plugin macro that allows you to use the P1 button. That what it'll actually do is you could program the macro for any size dowels, but once you go ahead and you home your machine and bring it to this outside location here, you push the P1 button and it'll automatically move the gantry or the end mill over to this location. So it'll offset up and to the right 1/8 of an inch. Okay, so that's kind of cool, and I'll make that macro available to anybody who's using UCC CNC. Another option is, depending on what software you're using, you can maybe program in your profile that you want to have an offset. You could use work coordinate systems, so you could use like G54, 5, or 6 to establish a 0 point that's here as opposed to here. So there's a few different things you can do there to do that, but I just wanted to illustrate that what will happen when you put the dowel pins is your 0, 0 is actually going to be right here, and we need to move it to here in order for all the jobs that you put up against these pins to be accurate. Okay. Now the other thing that we want to look at here is the program to write the pins. So what's going to happen now in Vectric, if you move your gantry all the way to the left and all the way to the bottom, and you try to program a job with Vectric where the dowel pins are on the outside. So say I grab these and I try to do a drilling toolpath to put these holes in. Vectric will actually put in the G-code that I want to move the pin or the end mill negative. So I want to go negative half the diameter of this, so negative 0.125 in X and negative 0.125 in Y. But if your machine is already at its maximum left and down and forward extremities, you can't move it any more negative. Okay, so like on our machine, we'll get a out of limits error and it won't do anything. Okay, so to fix this problem, so to be able to use Vectric to position your holes on your table, what you need to do is you need to change it so that you put the circles where the dowel pins are going to go on the edge. Okay, and what'll happen here now is if you look at the coordinate for this circle, right? This circle right now is set up for X0, right? Which means I'm at my maximum left X position, and I'm going to go up Y 1 inch. Okay, so if I look at this one, I am at X 1 inch, so I want to go 1 inch over, but I'm at Y0, which is at the maximum front Y position. All right, so the easiest way to put these dowel pins to ensure you're at your extremity is to move your gantry again all the way to the left, all the way to the front, and then create a tool path with the end mill, with the pins where the end mill is going to go on these center axes. Okay, so you can do a simple hole drilling tool path here like this, and so just do a drilling tool path. I would use, if I'm going to do 1/4 inch dowel pins, I'm going to run a 1/4 inch end mill on that. I don't need to use peck drilling. Now my dowel pins are 1/2 inch long. I'm actually going to order 3/4 inch long. So for now, I'm going to run the hole down 1/4 inch. So that way my dowel pin sticks up 1/4 inch, and it's in the table a 1/4 inch. Now it's always better to go into the table more than that, because if you accidentally have like heavy material and you push it up against these dowel pins, if it's an MDF table and you hit it hard enough, you could potentially chip out the MDF, or the pin might loosen up. So it's better to go into the table as much as you can. So that's basically it. Now, what I'm going to end up doing when you preview this, you won't see it correctly, but what you'll notice here is that half of the hole is actually going in the material, and then of course the other half of the hole would be on the outside, which you don't see in Vectric. So now, once you do this on your machine, now you're going to go ahead and have a new rectangular position here, which will be from this edge to this edge. Now, if you look at this, when you line your material up to the end mill, you're actually moved over 1/8 of an inch from the extremity position of your machine. Okay, so if you look at this here, go from here to the line, you can see right here, I'm 1/8 of an inch over. So that's why you need to have an offset set to move your start reference point from this position here to this position here for your end mill. And as long as you do that, everything else is going to work out just fine on this. And again, it depends on the machine you're using as far as how you can set that offset. Again, anybody watching this video choosing UCC CNC, we'll have a link to a macro that you can download and just install in your program, and you just hit that one button, it'll automatically move the end mill from outside to the corner every time. So even if you mess up and you reset your zero somewhere else, if you hit that button, it resets it right to this position. So if you have to do a repeatable job and you need to have a work guide system on the lower left, this is the easiest way to do it, using just steel dowel pins. Now, again, like I said, I know a lot of you are going to think, oh, well, I cut like an L out of MDF or aluminum or something. There's a lot of different ways you can do this, and the premise on how you'll do it and how you'll set your XY0 with an offset is exactly the same. Because if I put a piece of MDF over here on my table, and then I ran a profile cut down this line and across this line, essentially I've done the exact same thing, because I'm going to cut on the profile, which is going to be on the same thing as the edge of the dowel pin. All right, so it's basically exactly the same, but you're still going to have the issue where you have to move the XY0 from out here to here, because you got to get it inside 1/8 of an inch. Now, if you're going to use larger dowel pins, again, instead of moving your offset over 1/8 of an inch, you'll move your offset over half the diameter, whatever the radius is for that dowel pin diameter. So if you're going 1/8 inch, you're going to move it 1/16 of an inch over. If you're using 1/2 inch, you're going to move it 1/4 inch over. So that's basically, I hope this explains this properly, because it's very, very simple, and it's super helpful to have this located on your machine when you're running, to have a repeatable edge and guide to put the material in the same spot every time. So if you have any questions on this, please don't hesitate to drop me an email or leave a comment for this video, and I'll try to clarify things as best as possible. Now, I'm going to add in some footage on this video of putting the holes on the machine and showing how the work material works. So hopefully with a mixture of that plus this explanation here, you should be fine. Okay, so the first thing that we want to do here is we want to make sure that we home our machine. So we're going to home it. It's going to park the machine in the back left corner. And this is the machine's mechanical home point. And this is now the home point with regards to the mechanical limit switches that are on the CNC. Now, this will apply to most CNCs on the market. I don't know of one that doesn't have a homing feature, so everything is going to start with that homing feature. Okay, now we're using UCC CNC for this. Now, everything I'm going to show you will apply to other control software as well. Specifically, Mach 3 is a very popular one, so just because I'm using UCC CNC does not mean that the stuff that I'm showing you in this video won't apply to you. So in this particular case right now, what I want to do is make sure that I'm in machine mode here. So I don't really care about the soft position of the DRO. What I care about is making sure that I'm in machine mode. And right now I can see that my X is at 0, my Z is 0, and my Y is 2464 millimeters, which is in the back of the machine. So what I want to do now is I want to go ahead and move the Y-axis forward until it's all the way to the front of the machine. Okay, now that my DRO is reading 000, that is telling me that that is the maximum travel I have on this machine to bring me to the front left corner, okay? And this is really important. I want to make sure that I'm all the way forward and all the way to the left before I do the next step, which is going to be locating the holes for the alignment pins. And I want to make sure that my end mill is going to be even with the surface of the table. Okay. Now, the next thing I need to check is I'm going to actually go to 0 on my machine. Okay. And that is going to bring my end mill right to the surface of the table. Now, what I need to be careful of is I need to make sure that I have enough Z travel, because on this machine I'm going to be putting their 1/2 inch long dowel pins that I'm going to be going 1/4 of an inch down into the table. So I need to make sure that I have at least 1/4 inch of travel on the machine. So sometimes, due to the stick out of the end mill, when you come down to the table, you may find that you don't have enough Z travel to go any lower. So the only solution there is to either get a longer end mill or make the end mill stick out of your tool holder a little bit more. So at this point, what I want to do is, since this is my 0 location, I'm going to actually go ahead now and we're going to measure over just to see where the dowel pin holes will end up on the X-axis. On the Y-axis, I'm going to put one at 1 inch and I'm going to put another one at 8 inches. Now, depending on the size work material you do, you could actually put these anywhere you want on the board. You can go all the way down if you need to. The only thing in my case is I want to make sure that I never put a hole where a screw is, because it's a stainless steel screw. It's going to bust my end mill and possibly, do some damage to the spindle. So I want to avoid that. So I've already measured that out, and I know that this first screw is much further away than 8 inches, and I'm going to be 1 inch, which is going to put me here. Now, in this direction, I want to measure from the center of the end mill, and if I go 1 inch this direction, my hole is going to be really close to this hole that holds down my MDF board. So I want to go somewhere in the middle, and it looks like 1 3/8, so 1.375 should put me right about here, and that's good. That's where I want to be. I don't want to be next to the T-track, and I don't want to be next to the screw. Now, my second hole is, if I went 8 inches on my second hole, that would put the end mill, that would probably hit the screw. So what I'm going to do is move that over to roughly 9 1/4 inches, which is going to put my second hole right here. So everything should be all set now. I've got 1 inch and 8 inches. I got 1.375 and 9 1/4. Now you want to double check one last time to just ensure that the machine is in its 0 position. It can't move any more to the left, and it can't move any more to the front. Now we'll go ahead and we'll run our Vectric file. We'll put the holes in. And that's it. Pretty easy. Okay, these are the steel dowel pins that I'll be using. My dowel pins are 1/4 inch diameter. They're exactly 1/4 inch, and they're 1/2 inch long. I'm probably going to re-drill this tool path in the future, because I'd like the dowel pin to go a little deeper into the table. So I'm going to try to find 3/4 inch dowel pins And then I'll come back, I'll run the same toolpath again, except this time I'll change my depth to a 1/2 inch instead of a 1/4. So now all I have to do is take the dowel pins, put them in the holes I just made. They fit nice and snug. Perfect. So now, like I showed you in the Vectric file, when we move the machine back to our 0, 0 position for X and Y, that's going to put the end mill right down in this corner. Okay, so I'm going to lower for illustration, I'm going to lower this down. Now what I'm going to do is grab a piece of wood, scrap wood, and I want to place the scrap wood on my table up against my dowel pins. Okay? And what you'll notice now, I want you to pay attention to where the location is of the end mill. You notice that end mill is right outside the corner of this piece of wood. So what I need to do now is I need to make sure that when I start a job and I'm using this piece of material, that the center of my end mill is on the center of this corner right here of the wood. And as long as I do that, every job I do using these dowel pins for alignment, everything will be perfect and my measurements will be fine, as long as I make sure that the center of this end mill is in that corner. If I try to run a job right now, what's going to happen is my end mill is going to move over. So say I want to cut a hole that's 1 inch by 1 inch. That hole is actually going to be an 1/8 inch off in X and Y. Okay, I did this before and I ran a test hole leaving the machine in its 0, 0 position. And as you can see here, from the edge of the material to the center of the hole, I'm roughly off an 1/8 of an inch in that direction, and I'm off roughly an 1/8 of an inch in that direction. So that's a problem. Now what I need to do is I need to make sure that when I say I want this hole to be 1 inch, that it's actually 1 inch from both edges. So in order to fix that, I want to move my Y towards the back 1/8 of an inch, and I want to move my X towards the right 1/8 of an inch. And as you can see now, the center of my end mill is exactly on the corner of this material. Now I'm going to go ahead and I'm going to run the same job where I want to put a hole 1 inch to the right and 1 inch up on this material, and we'll measure it and we'll see that it's exactly 1 inch to the center of the circle. We're going to measure the location of this hole from the edge of the material to the center of the hole. I am at just about exactly 1 inch, and from the edge to the center I'm exactly 1 inch. So now, as long as I set up my end mill so that the center of the end mill is on this corner exactly, anything that I design in Vectric will be perfect in relation to that. So this hole I measured to be 1 inch by 1 inch in Vectric. That's where I wanted the hole position, and now I cut it and I measured it, and that's exactly where it is. Now, taking a look at UCC, right now I have my software 0 to 0, 0, and my Z, it was set to, after I touched it off, so it's set to 6.35 millimeters. Okay, that's where my end mill is right now in relation to the top of the material. So 0, 0, 0 was the top of that melamine that I was doing. I just moved it up a quarter. My job actually is set to end the job and start the job with the end mill 1/4 of an inch above the material. So that's where I'm at right here. Now what's important here is when I switch back to machine coordinates, you'll notice that while I'm in software 0, 0, 0, my machine coordinates are actually 3.175, which is an 1/8 of an inch to the right on Y and back on X. Now Z is at minus 0.89. That one doesn't really matter, because what happens on this machine is as I move the gantry up, the Z number goes down. Z0 is actually when the axis is all the way at the top. So because I had that set to 1/4 inch above my 0 point on my work material, that's why that number is negative. But what's more important is that my X and Y are now 1/8 of an inch over and back from my software 0. So that's important. In order to use these dowel pins and ensure that your end mill is always in the exact corner of your material, you have to make sure that your machine coordinates are 1/8 of an inch over and 1/8 of an inch back, which is exactly half the diameter of the dowel pin. Now, what we went and did, and any of you who are using UCC CNC, we actually wrote a macro that if I move my gantry over to some miscellaneous place, we wrote a macro that all I have to do is hit P1 and it's going to automatically move my 0 point to 3.175, which is 1/8 of an inch in X and Y. So it doesn't matter where my gantry is. If I mess up and I accidentally hit 0 all in this new location, so now that machine coordinate is not in the corner anymore, it's moved outward, but I hit 0 all by accident. So now technically I lost my 1/8 inch over and 1/8 inch up reference point. So on UCC CNC, all I have to do is hit P1. And my gantry will move automatically back over to 1/8 inch over and 1/8 inch in, and reset my DRO to make that the new 0 point. So this is really cool when you're using the dowel pins. I don't have to manually type in 1/8 inch offset in the DRO. I don't have to worry about moving the arrows manually. And I don't have to worry about, more importantly, if I reset my 0 all somewhere else on the table by accident, I don't have to worry about losing my reference point. All I have to do is hit P1. The machine will come back to 1/8 inch by 1/8 inch, and then it'll reset to 0 at that location.